Hi there, and welcome back to Chapter 1.1 from Stevens' Matrices, Vectors, and 3D Math. Here we're going to go through the worksheet problems at the end of this chapter. There are 3 problems. Each one consists of a system of equations where there are 3 equations and 3 unknowns. We're going to determine if there is a unique solution, and if there is, what is it? If there are infinitely many solutions, we're going to determine what the general solution is and one example of a particular solution. And if there are no solutions, we will determine that as well. Okay, so let's get started. We're going to start with number 1 here, and I have it written on some note paper on another sheet right here. So that's what it looks like with my chicken scratch. I'm going to move this to full page mode, and I guess make it full width. Okay, there we go. So the first thing I want to do is I want to get this system into augmented matrix form. So there's a 1, and notice there is no x2, so there's a 0 for x2 and a negative 3 for x3. The line delineating the coefficients from the constants, so that's 8. Then I have 2, 2, 9, 7. I have no x1, so that's 0. 5, sorry. The coefficient of x2 is 1. Coefficient of x3 is 5. And negative 2. Okay, so let's go, let's start this game, right? We already have a 1 in the top left, so that's good. What I really need to do is get rid of this 2. All right? So I'm going to multiply this first row by negative 2 and add it to the second row. All right? And I already have a 0 down here, so my first row stays the same. And so I'm going to have negative 2 times 1 plus 2 is 0. Negative 2 times 0 is 0 plus 2 is 2. Negative 2 times negative 3 is 6 plus 9 is 15. Negative 2 times 8 is negative 16 plus 7 is negative 9. And then I already have a 0 down here on my third row, first column, so that's good. I'm just going to copy it down. 0, 1, 5, negative 2. Right? Okay, so does that look right? I think I have everything together. Okay, so far so good. So now I would like to get a 1 in this position. But if I divide that row by 2, I'm going to get a fraction. I don't like that. So instead, noticing that I have a 1 in this position, I can switch those 2 rows and have a 1 where I want it. So the first row remains unchanged. The second row is the third row, so it's 0, 1, 5, negative 2. And then the third row becomes the second row. 0, 2, 15, negative 9. Alright, so far so good. So I want to make this 2 a 0. So I'm going to multiply the second row by negative 2 and add it to the third row. So notice the first row nothing happens to, so I just rewrite that. 0, nothing. I'm not doing anything to the second row either. And now this is where things change. I'm going to take negative 2 times 1 is negative 2 plus 2 is 0. Right? And by the way, nothing happens. When I take negative 2 times 0, add it to 0, I still have 0 here. Okay. So negative 2 times 5 is negative 10 plus 15 is 5. Negative 2 times negative 2 is 4, plus negative 9 is negative 5. All right? And I think that looks good so far. Yeah. So now I'm almost there. I just want this 5 to be a 1. So I'm going to multiply this row by 1/5. Unfortunately, I don't get any fractions. So I have 1, 0, -3, 8, 0, 1, 5, -2, 0, 0, 1, -1. Okay, so things are looking great. If I take, now I'm going to do the back substitution part. By the way, this is row echelon form. Alright, I have 1s on the diagonal, 0s below it. Things are looking good. I'm going to get a nice unique solution here. So that last equation, represented by row 3, basically says x3, am I doing indexes or x, y's, and z's? Indexes. So that last row says x3 equals -1. Great. I love that equation. It actually gives me the value for my third variable, x sub 3. So now I look at row 2, and that is x2 plus 5x3 equals -2. But x3 is this -1. So that's x2 plus -5, right? 5 times -1 is -5 equals -2. So I'll add 5 to both sides. x2 equals 3. And I'm getting there. And then from row 1, I have x1 plus 0x2, which I won't write down, minus 3x3 equals 8. And x3 is just -1, so that's x1 minus 3 times -1, which is -3, so that's just plus 3, equals 8. And I subtract 3 from both sides. x1 equals 5. All right, so I have my solution. x1 equals 5, x2 equals 3, x3 equals -1. I have a unique solution. So that's great. 5, 3, -1. So now let's go to the second problem. We probably won't get so lucky, right? Let me get it into widescreen. There we go. Okay, following the same procedure, I'm going to put this in augmented matrix form. So that I have no x1, so that's 0, 1, -4, 8. 2, -3, 2, 1. 5, -8, 7, 1. All right. So I have it in augmented matrix form. And now let's see. The first thing I want to do is get a 1 right there, but I have a 0 there, so I'm going to have to switch this row out. So let's just switch row 1 and row 2. I could switch it with row 3, but I'm looking like I'm going to get some fractions no matter how I do this. So I'd rather have 1/2 than 1/5. So I'll switch row 2 and row 1. So this is going to give me 2, -3, 2, 1. 0, 1, -4, 8. And then 5, -8, 7, 1. And now I want a 1 here. So I'm going to multiply this row by 1/2. Or divide it by 2, whichever one you prefer. So that's going to give me 1, -3/2, 1, 1/2. Remember, you have to do it to the whole row, not just the column you want. And I'll just transcribe the remaining rows as is. -8, 7, 1. Okay, so I want to get rid of this 5. Right? I want that to become a 0. So I'm going to take this row, I'm going to multiply it by -5, and I'm going to add it to the third row. The nice thing is I already have a 0 here, so I don't have to worry about that. I generally would start by making that 0. Okay, so I'm going to first transcribe everything and then do the row operation. 0, 1, negative 4, 8. Okay, so I'm not looking forward to this because there's fractions. So negative 5 times 1 is negative 5 plus 5 is 0. That's why I chose the negative 5 in the first place. Negative 5 times 3 halves is what? 15 halves. And I have to add that to negative 8, or minus 16 halves, which gives me negative 1/2. Now, negative 5 times 1 plus 7 is going to give me 2. And then negative 5 times 1/2 plus 1. Let's see, that's negative 5 halves plus 1, or plus 2 halves. That's negative 3 halves. All right. I think that's it. Yeah, that looks good. Okay, so now I would like to have a 1 here. I'm lucky because I do have a 1 there. And so what am I going to do? There's a few things I could do. I don't like these fractions here, but we can keep. You can actually eliminate those fractions by multiplying the whole row by 2. But let's suppose we don't do that. Instead, I need to multiply this row by 1/2 and add it to that row. Let me do it over here on the right. I'm going to multiply this by 1/2 and add it to the third row. So I'm just going to transcribe the first row and the second row. And then I'm going to get this 0, so 1/2 times 1 plus negative 1/2 is 0. That's why I chose the 1/2. 1/2 times negative 4 is negative 2, plus 2 is 0. 1/2 times 8 is 4, minus 3 halves. Alright, so that's 8 halves minus 3 halves. Alright, 8 halves, so that's 5 halves. Doesn't much matter what it is, because if you look at this last row, as long as it's not 0, this last row says 0 times x1 plus 0 times x2 plus 0 times x3 equals 5 halves. And that cannot happen. So in this case, there are no solutions. Right? So problem number 2, no solution. So I'm guessing if problem number 1 had a unique solution, problem number 2 had no solutions, I'm guessing problem number 3 has infinitely many solutions. Let's see if that's the case. So I will convert this to augmented matrix form. 1, 6, 2, 10. 1, 5, there's no x3, so I get a 0 there. 6, no x1, so I get a 0 there. 1, 2, 4. Alright, so getting things started, remember I want to go to row echelon form, which has zeros below the diagonal, which are 1s, and then other stuff up here. Right? Okay, so I've got my 1, that's great. I've got a 0 down there at the bottom, that's good too. So I need to get rid of this 1. Right. So what I'm going to do is I'm just going to multiply this first row by negative 1 and add it to the second row. 1, 6, 2, 10, that's just the first row, nothing changes. Multiply 1 by negative 1 and add it to 1, you get 0, that's why we chose negative 1. Multiply 6 by negative 1, you get negative 6 plus 5 is negative 1. Multiply 2 by negative 1, you get negative 2 plus 0 is negative 2. Multiply 10 by negative 1 and add it to 6, you get negative 4. And then I already have a 0 down here, so I'm good to go. I'm just going to rewrite that row. Okay, great. So, I wish this was a 1. I could do one of two things. It doesn't really matter. I could switch these two rows, or I could multiply row 2 by negative 1. And as it turns out, it won't really matter which one I do. Let's suppose let's multiply this. Let's switch them. We'll just switch the rows. So we get 1, 6, 2, 10, 0, 1, 2, 4, and then 0, negative 1, negative 2, negative 4. All right. And so what we're going to do, now we want to get rid of this last row. I mean, we don't actually want to get rid of the whole row. It just actually happens, right? I want this to be a 0. So all I have to do is add 1 times this equation, or 1 times the second equation, and add it to the third. And when you do that, you get 1, 6, 2, 10, 0, 1, 2, 4. 0, 1 times 1 is 1, plus negative 1 is 0. That's why I just multiply by 1. 2 plus negative 2 is 0. 4 plus negative 4 is 0. And if you notice, this last equation basically says 0 times x1 plus 0 times x2 plus 0 times x3 equals 0. That is a useless equation, right? It adds nothing to our solution. So I'm going to get rid of that. All it does let us know we have infinitely many solutions. So I'm going to let x3 be a free variable. All right? And so that's just, I'm just starting off that way. And so now if I look at this equation, row 2, that basically says x2 plus 2x3 equals 4. And I'm going to let x3 equal t, so that's x2 plus 2t equals 4, or x2 equals 4 minus 2t. All right? So I'm getting there. I have infinitely many solutions, and I'm working on here the general solution. So then if I go to row 1, now remember I'm just doing back substitution, that says x1 plus 6x2 plus 2x3 equals 10. Right? I'm just looking at this row right here. And let's see. That's x1 plus 6. x2 comes from here. That's 4 minus 2t. Plus 2 times x3, which is just t, equals 10. So, distributing and collecting like terms, I'm going to get x1 plus 24 minus 12t plus 2t equals 10. Now first, well, let's see. I'll subtract 24 from both sides and combine my t's. So I get x1 minus 10t equals, let's see, 10 minus 24, negative 14. So x1 equals negative 14 plus 10t. Right? So there we go. I have x3, x2, and x1. So the general solution looks like this. I'll put it in sort of a column vector here. x1, x2, x3 equals, let's see, that's negative 14 plus 10t, 4 minus 2t, and t. Alright, so that's the general solution. That means there's infinitely many. T can be any number you want. Right? And one particular solution, and again, there's infinitely many. We'll just let t equal 0. And you get x1, x2, x3 equals, what do we have here? T is 0, I get negative 14, 4, 0. And that is the specific solution. It's not the specific solutions, it is a specific solution, or a particular solution. Again, there's infinitely many, and there's the general solution. That describes all of the solutions. So there we have it. 3 different systems of equations. In this case, we had a unique solution. In this case, we had none. And in this case, we had infinitely many. And that's really the trick whenever it comes to solving systems of equations. Gaussian elimination and back substitution will get you there every time if there is a unique solution. But oftentimes, there are no solutions or infinitely many. And so you have to proceed with caution as you do these problems. And so that wraps it up for the worksheet and for Chapter 1.1 in general. And I will see you in Chapter 1.2. Bye now.